glad that scores went up. Boy, some people went up by 15 points on this last exam. It was awesome. The high score, just so you know, was 108. Okay? Yeah. And it wasn't in this section. It was in the next section. But that just tells you how well people did on this. And I don't know what made the difference. Was it because you had recordings you could go back to, or was it, what?
The recordings helped a lot.
Yeah. So yeah, unfortunately this class is not like in a hybrid modality, and it's not high flex. So yeah, so I'm glad that did help, and that's cool. How many are gonna come Sunday? Good. Okay, we'll meet in here, and yeah, the other sections will be joining us. There's two other sections that will be joining us. So yeah, get here. I'll open the doors around 9 or something. So come on in. You're welcome to bring snacks to share. What we're gonna do is we're gonna, like I said before, we're gonna play a couple of games and also do case studies. Get practice with that. And you've been doing case studies in lab, correct?
Yes.
Good. All right. Let's try one today. All right. So don't use your notes. Use your brain. Okay. You're not going to be turning this in. Try and do it by yourself, because your partners won't be there to help you with the exam. So see if you can do this one.
Have you seen that show?
Okay, give you a couple minutes to finish up here. Raise your hand if you're all done with it. It's pretty straightforward. Okay. All right, couple minutes here. Okay, let's see what you got. Okay. All right, as you read through this, what stood out in your mind? Bloody cough. Usually when you have a bloody cough, what two things happen? What are the two things you should think about? Pneumonia, and what else? TB, okay? Is this pneumonia? No. Usually with pneumonia, what happens? What symptomology is different? What? Yeah, you get symptoms faster. Pneumonia, remember, is oftentimes bacterial, right? And so things come on. This has been going on for a long time, right? Okay, so what disease do you think it is? TB. Okay, how come it's not coccidiomycosis? What is the other name for coccidiomycosis? Coccidiomycosis, yeah. Okay. Oh.
Is that walking pneumonia?
No. Valley fever, right? San Joaquin Valley fever, okay. All right. How is this spread? Direct contact and droplet, right. Direct contact and droplet, okay. Drugs? INH is the one. As soon as you see TB, you should think of INH, okay? And what are the signs or symptoms that may occur that were not described by the patient? Night sweats, yeah, okay. All right, how many of you got 4 out of 4? Okay, how many got 3 out of 4? Okay, all right, that's good. Okay, so you can kind of see how, I mean, you're going to have a lot of these on the exam. We're going to go through a ton of case studies during the review on Sunday. Okay, but now, I mean, what are you trying to do? You're trying to integrate your cards, integrate everything that you learned from your cards so you can apply it. Okay, how many have started the worksheet that was posted? Okay, good. Somebody's already completed it. Take a look at that. Try and do that from memory, not using your cards. I know it's super easy. Oh, I can put it into AI. It'll be done in 30 seconds. What good is that going to do you for the exam? So, yeah, that's, you know, I know that's a possibility and people will use it. That's great. That's why it's only worth 5 points. Is because, but if you really want to get something out of it, do it from memory as much as you can. Okay? Is that cool? All right, okay. Now, you have everything. Everything, you know, we're a week out. This is officially dead week. So I'm not going to assign any, I mean, we have a Quizzy Wizzy, but there's no new material. I mean, there's only, you've seen everything. Everything's been published. You filled in all your blanks. Is that correct? Okay, if you haven't done that, I'm not going to do, you know, oh, here's this slide. This is what goes on this slide. Okay, we're kind of past that. This is the last week. We've got to finish 15, 16, 17, and then what do we have on Wednesday? Our last quiz, right? Our last quiz. And it will be the same format as all the other quizzes, some multiple choice, true, false, and all sorts.
Is that going to be open?
No. No, you're done. Yeah, you've got to do from memory. No cards. Yeah.
It's not going to be case studies, right?
No, it's going to be that information from your cards. Okay? All right. Yeah.
It's all cards, correct?
It's all cards. Yes. If you're not sure, go back to the syllabus. It tells you exactly what I'm going to ask. Okay? It tells you exactly what I'm going to ask. Now, how many of you have made a mama sheet with all your cards? Okay, if you haven't, I would do that. It is going to help you tremendously. We talked about it back in the early weeks of the semesters, is to make a monosheet. Please do that. It will help. Okay? Don't wait till Sunday night to do it. Do it now, so you can have a little less than a week to review. Does that make sense? Okay? For those of you who have monosheets, does it help? Yeah? Okay. You gotta make it and then learn it. So, takes a while. Okay. Cool beans. So, I am smiling under this. I know, I can't tell. It's so hard to breathe through this. Okay. All right. So, let's start with a little chalk talk here. Okay. On chapter 15, part 2. Okay. And you've had the answers up now for over a week, so I hope that you filled in the blanks. Okay. Because we're going to talk about applications of immunity. And I want to kind of do a little review along with doing the applications of immunity. Okay? So, here you are. Yay. Here we go. I was just testing the screen here. Okay. So, there you are. You've got your immune system. You're about 20 years old, 30 years old, 40 years old, 100 years old. Okay, right there. Okay? And you get a vaccine. Okay? Here's the big shot. We'll make it big. Okay. Yeah, it doesn't really work that way. Tell me what's going to happen in your immune system. What is your immune system going to produce? Okay. What's the first thing it will produce? Antigens is what stimulates the immune system. You're not going to produce antigens. Antibodies. What are the antibodies? IgG, IgA, D, E. Which one shows up first? IgM, right? Why do we like IgM? How many prongs does it have? How many binding sites? 10, right. Yeah, it's got 10, it's got a lot. Okay, so antibodies. Now, if this is something new that you've never seen before, how long does it take to get that antibody response?
21 days.
About 21 days, and that is if you're healthy, okay? And you don't have any nutritional deficiencies, like any protein deficiencies, 21 days, okay? Now, we have seen this in action, right? When did we see this? COVID, right? A lot of patients were gone by 21 days. They couldn't even get a good immune response by 21 days, okay? All right, so we've talked about the antibodies. What are the antibodies made of? Proteins, yes, they're made of proteins. Okay. All right. So, what are the other things your immune system is going to do with this? Okay. What kind of memory cells? Okay, B memory cells. Okay. And what other cells? T memory cells. Okay. So far, so good. How long does that take? Well, it takes about 21 days, first round, okay? Up to 21 days. B cells are part of what kind of immunity? Humoral. What is our T cells part of? Cell mediated. Okay? The memory cells, okay, are great. Oh, I didn't ask. What cell makes the antibodies?
Plasma.
Plasma cells, right. That it comes from where?
From the B cells.
From the B cells. Good. Okay. All right. So, how long do the antibodies stick around? 90 days. Okay. So, if you got an immunization for measles, what's the immunization for measles? What is it called? MMR. Measles, mumps, rubella. Okay. And when do you get your measles series? When you're a little kid, when you're a baby, okay? You get that series when you're a baby, okay? Has anybody in here gotten measles, mumps, or rubella? That works pretty well then. So is it antibodies, B cells, or T cells that are causing you to have such great resistance to this? It's the B and the T cells, right? It's the B and the T cells that are allowing you to do that. So whenever you get a vaccination, it's not just the antibodies. The antibodies are pretty short-lived. They're about 90 days. Okay? Now, before, let me ask you, is measles, mumps, and rubella going around in the population right now?
Yes.
Absolutely. Okay? Yeah, you're getting exposed all the time, but you're not getting sick. So that tells you you've got pretty good memory in B cells and T cells. So, tell me what's going to happen. Let's say you get measles. You get exposed to measles. What's going to kick in? Out of this, what will kick in first? The memory cells, the B and the T cells. The B cells will go ahead and make antibodies, and these will do cell-mediated responses. Okay. Before you go into the nursing program, you're going to have to get a bunch of vaccinations, right? Okay. What do they test you for? What do they make sure you have? TB. They check your measles titer before they give you a booster. Sometimes, some of you will need a booster. Okay. What other series do they give you?
COVID.
Hepatitis. What? Varicella. Yeah, all the goodies. Why do they do that before you start the nursing program? Can you be in clinicals going across the street where there's everything, right? Yeah. So, okay. All right. So, now, once you get that vaccination, okay, and let's say you're outside and you do get exposed to measles. How long before you get antibodies to that? If you're vaccinated, how long does it take you to make antibodies? No, that's way too quick. Try about 7 days, okay? It's about 7 days, all right? That's a whole lot less than 21. So is it possible that you are fighting an infection that you have gotten vaccinated for right now? Could you be fighting an infection? Absolutely, absolutely. That you got vaccinated for a long time ago. Okay, is that cool? All right. So, where did the first vaccinations come from? Who's responsible for the first vaccinations? It was Jenner, right? Okay. And what did he vaccinate against? Okay, he saw milkmaids that got cowpox, which is a lot less deadly. Okay, and they saw a crossover to smallpox. That if they had cowpox and they had been, had the little pox, they had some cross protection for smallpox. Which one was deadlier? Smallpox is. Smallpox is horrible. You see pictures of it, that doesn't really even do it justice. You get these horrible, horrible vesicles all over. And then as they're painful, and then as they go down, they have a little BB in it, and you're scarred for life. And it's happening inside, outside, everywhere. That is not something we want. Okay? And why do we call it a vaccination? Vaca. What is vaca in Spanish? Cow. Yep. Okay. So, the last time that we had community-acquired smallpox was in 1976. Okay? They used to immunize everybody in the U.S. for smallpox up until about 1968. Okay? If you're in the military, you get a vaccination against smallpox. Why would they do that?
Because you're traveling around.
Okay, you're traveling abroad, and smallpox is part of that group of horrible illnesses that people like to weaponize. So when we're out in the field, we don't want to have this, have someone introduce smallpox. Do we still have the virus around? Oh yeah, it's stored in labs, who knows who's got a copy of it. But, yeah, so we want to, that's why they do vaccinate the military. Okay, so, all right. Now, let me ask you some more general vaccine questions. Okay? Do we have vaccines for everything?
No.
Okay. I'm going to put a bunch of things up here, and I want you to tell me. Give me a minute here. Okay. So, okay. Take a look at this list and tell me which ones we have vaccines for. Whoops, there we go. Okay. Yeah. Which ones do you have vaccines for? Okay. For influenza, Hep A, Hep B, tetanus, mumps,
Bird flu. Isn't that?
did we get them all?
I'm pretty sure the flu shot protects against it. Not a lot of people get the flu shot.
Okay. We do have a bird flu vaccine that's in restricted use. Okay, and who's getting them? Mostly farm workers that are exposed to bird flu. We haven't heard too much about it lately, but it's still going around. What state has the most cases? California by far. Okay, now let me ask you a question. Oh, I should put one on here. HIV. Do we have a vaccine for HIV?
No.
No. Okay. So, yeah. So is it possible to make a vaccine to everything?
No.
No. How come? Okay, if you've got something that's changing, the antigenic characterization of that is changing, you can't make a vaccine to it. Okay? Because in order to have a vaccine, what has to happen? You have to be able to put the antigen in or some modification of the antigen in, and then your immune system has to respond. Okay? The RSV vaccine took a long time to develop. Why? Because it does something funky when it gets in the cell and changes shape. So it was almost impossible to get a vaccine until they changed platforms. Okay? Is that cool? All right. Good. Okay. So, yeah, this is interesting about vaccinations. Okay? And we've got 3 to 5 million children that have not been vaccinated. Okay? So, what are some of the things that you hear from people that say, oh, I'm not going to get vaccinated? What are some of the things you hear? Mercury causes autism. We know that's not true, right? Andrew Wakefield, boy, he really screwed up World Health. Thank you so much. Yeah?
I've heard theories about the government putting microchips in there.
Yeah, our government can't even get the tax system right. You think they're smart enough to do that? Really? Okay. Microchips. What else?
Causes autism.
Yeah. Okay. Causes autism. What else? Yeah.
For flu, they say that you get the flu after you get the vaccine.
Okay. You get sick. Okay. Yeah. Herd immunity. And that's not a reason to get it? Oh, okay, so somebody else did okay. Okay. Herd immunity. What else? Yeah.
They're healthy, so we don't need to do it.
Yeah, I worked well with COVID. All right, yeah.
They know someone that like died from the vaccine.
Oh, yeah. Yeah, they died. Their arms fell off after they got the vaccine. What else?
They're scared of the ingredients.
Okay, scared of ingredients. Eye of newt. Okay. What other reasons have you heard? Oh, too quick a production. Okay, too quick. Oh, they made it too fast. Yeah. Okay. Herbal. Yeah. Okay, side effects.
Misinformation.
Yeah. Oh, boy. Okay, what else? Yeah.
Not sure which vaccine to get.
Okay, not sure of the schedule. Okay. What else? Age, in terms of what?
I have patients whose parents won't vaccinate them because they think they're too young.
Oh yeah, we keep their parents
Okay. Yeah. What?
Natural immunity.
Oh, they want natural immunity. Okay. Oh, I heard this a lot. It changes your DNA. Yeah? Okay, so. Okay, so. Okay. My neighbor came over a lot after I got back from my first appointment during COVID. And she was crying, she was so upset, because she said, there's fetal tissue. I don't know if you heard that.
Oh, from like the mRNA. They use like stem cells.
Yeah. So she's like, how can you be a Christian and believe that? And I'm like, I don't. Okay? I don't believe it. Okay, what else? Anything else on here? Okay, so, you know, you're going to run into all sorts of things. COVID was just a warm-up, okay, to things that you're going to run into. And for those of you that were on the front lines, I mean, I was there. I saw patients that denied that there was even a virus as we're intubating them and they died. Okay? Oh no, this was all made up by the government. I'm like, well, really? You know, while you're doing CPR on them, they just told you a while ago that, hey, you know, this was all made up. Okay? I know that there, you know, unfortunately with COVID, everything got politicized, and I'm going to be the first to say that public health really made some mistakes in how they messaged it and how they educated people. And so what's going to happen, and what's happening now in public health, is that people don't want to vaccinate their kids because of all this craziness. And they'd rather use social media for education than the people that go to school for all these years. Now, you're going to be treating somebody, if you haven't already, and they're going to be on Dr. Google, right, which we know is always perfect, or AI, which is always perfect. And you're going to have to explain this. So it is critical that you understand how vaccines work, you understand the drawbacks, you understand the benefit, okay? It's not just about reading a bunch of slides and filling in the blanks, okay? This is going to impact everybody's health, not just yours. And you need some tools in your tool belt when you hear stuff like this, right? When you hear stuff like this, I'm not going to vaccine. How many's had a reaction to a vaccine? Okay, what were your reactions?
I know I had that just like little spotting on it and never went away after one vaccine. I had that
Oh, really? So you still got your spot?
Yeah.
Right on, okay. Cool. Decorative. Okay, so, yeah, what other reactions have you had?
With the COVID, I hear that
You got sick. How many got sick with the COVID vaccination? Okay, all right, yeah?
I had seizures after it, but I also had epilepsy, so it was just triggered.
Okay, all right, let's talk about that for a moment, okay? I'm not saying that you did this, and I'm not doing, but we're just gonna use this as an example, okay? You post on social media, I got the COVID vaccine and had seizures. What message does that send out? It's dangerous, no, they didn't went too fast, blah, 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 blah. But what's the reality? She has a seizure disorder, right? Okay, when I got the bivalent one, I got cardiomyopathy, okay? But I'm already susceptible, okay? Was it expected? No. Did it suck? Yes. Your seizures sucked, right? Okay. But is that a reason that everybody shouldn't get vaccinated? No. No, because what are we trying to achieve with vaccinations? We have two objectives with vaccination, okay? The first objective with the vaccination is that you want to protect the health of the individual. That is the first objective. Second objective of a vaccination is to produce something called herd immunity, okay? And we'll see a little bit how that works. Is that good? Yeah. Okay, hopefully you wrote those down, okay? Because those are really why you do a vaccination. Yeah.
What is that word together? I'm not sure of what.
Schedule. The vaccine schedule. Yeah. Okay? Because when we look at everything, here we go. Where did it go? Come on. I don't want to do that. Just show me the. Okay. When we look at anti-vaxxers, okay, anti-vaxxers was a long time ago. I mean, it started a long time ago. But anti-vaxxers have been around forever, okay? Why? All right. So let's address some of these things. So you have this information for you, okay? First of all, is there a microchip in the vaccination? No. I'd be more worried about this thing that you carry to and you're tethered to every day. This is listening to you, right? You know it is. These ads show up after you talk about something or that. And you're worried about being followed? Oh, I don't want to get that, but I'm going to keep this right here so I have it all the time, right? Okay, we already got a microchip and you volunteered. Okay, all right. Okay, scared of the ingredients. There's fetal tissue. Okay, scared of the ingredients. When you go to get a vaccination, how many of you read the sheet that comes along with the vaccine? Good. How come you read it?
I always like to read all of the things that I could.
Oh, good.
Medication, because I might be sort of so I need to.
Oh, so you open it up and it's huge and
Oh,
has
yeah.
all the stuff in there. Okay.
I also, it's a good to also just do your own research on any vaccination if you want to do, as a precaution.
Yeah.
I think that's just.
I think it's a good idea. I do it with my kids all the time. Yeah, sit. Allergic reactions, right? Okay. Was there fetal tissue in the COVID? No, there wasn't. I don't know where they got started. I don't even know. And I asked my neighbor this. I mean, she's such a sweet lady, and she was so upset. I said, "Where did you hear that?" "Oh, I saw something on Facebook." Oh my God. Yeah. Okay. Well, no. Now, is it possible that they use stem cells to do some research? Sure, but stem cells are used all the time. Do they, how do you get stem cells? You order them from the stem cell store. Okay, there are cell repositories that you can order them. You can order stem cell lines, they're cells. Now, was it used in the research? I don't know. All this was pretty proprietary, so. Okay, let's talk about this one. Too quick a production. How long has the mRNA platform been around? Years. Okay? And one of the scientists that developed the messenger RNA platform had a seminar at the UCR Medical School. And they invited all RCC students to watch. Now, we were all locked down at the time, so we got to watch it on the screen. But he spent his whole career looking at, at the National Institutes of Health, looking at how to use mRNA. What are they using this mRNA platform for now? Now that it's gotten a lot of attention, a lot of funding, they're using it for cancer, they're using it to treat genetic diseases. This is amazing, because what do? You just put a section of mRNA into a little droplet of fat. And when you do that, okay, what happens when you have two cells that have got fat, goo, waxy stuff come together? What do? They merge, right? Membranes merge. And so they come together, and the mRNA can then what? Enter the cell. Now, does the mRNA ever go into the nucleus? Not really. I mean, there's some pores there. You might be able to get some in. But is there a way to integrate messenger RNA into the DNA? No, we don't have a method to do that. Okay? So where does the mRNA stay? It stays on that cytoplasm, and what happens to it? It gets translated into proteins that get secreted out, and now your antibodies can react to it. And your cell-mediated, because this is a foreign protein, right? We just did this. You get a foreign protein, what are you going to do? Start making, it acts as an antigen, and you start making antibodies for all of that good stuff. Okay, that's really how mRNA vaccines work. Now, if we could get, and this is what's happening down the road, if, literally just down the road, if you get a protein that's on the surface of a cancer cell, let's say you've got a cancer cell and you've got some, awful protein that's on this surface here. Could you make an mRNA vaccine that would target that? Absolutely. What would you do? Get your little thing, cover it in some fat. Okay, the mRNA goes into here. This mRNA is going to have information about these, and your cells are going to make these, secrete them. Now what happens? Now your body's going to make antibodies and B memory cells. And when it does that, it can attack the cancer cells. Isn't that cool? I mean, this is changing therapy. Okay? And now this gets eliminated. Okay? This platform is being used like that today. Not tomorrow, but last week. Okay? This has really changed how we do things. Isn't that cool? What a time to be alive. I mean, this is really neat. Okay. So, let's go here. Does it change your DNA? No. Does it cause us autism? No. Have people died?
Yes.
Yeah. Okay. So, I don't know if you checked this out in the module. Here we go. This is a national database of reporting an adverse effect. CARES. Have you ever seen this? Okay, did anybody play around with this a little bit? Okay. Anybody in the United States can, or outside of the country, can report an adverse event to a vaccine. Okay? Alright? And then it gets incorporated into the data, which anybody can search. Okay? So you want to know, oh, what happens with my tetanus? I cut my hand, I got a tetanus shot with it. This is where you go. Okay? Are they keeping track of it? Yes. Physicians put stuff in here. Nurses put some in here. Pharmacists put things in here. People, general, not medically related people put things in here. Okay? This has been going on for a while, before COVID. Okay? But now you know where to find the information. Yeah?
Is there a reason why it says that it's being modified?
Yeah.
I can't read.
This website is being modified to comply with President Trump's executive orders.
Oh, are you kidding?
No. No, science is being decimated right now. Okay? Yeah. Because National Institutes of Health, National Cancer, we had an NIH grant here, Bridges to Baccalaureate for those who want to go into medicine. That was canceled. We don't have it anymore. I have a federal grant right now. I'm expecting it to get canceled any day. Okay? I mean, look at what's going on in science. Are we going to get better or worse at tracking? It's going to be worse. So you got to be smart, right? You got to be smart about it. Okay? All right. Okay. Let's take a look at this. Okay. We see dramatic decreases when we do have vaccinations. Okay? Oh, here's another one I should have talked about. Oh, when I get the vaccine, I get sick. Okay? I took a flu vaccine. Oh, I got the flu the next day. Is it from the vaccine? No! How could it be? It takes 21 days to get antibodies, maybe 7. Okay? What did it do? It probably lowered your immunity a bit, and you might have been fighting something else, and so yeah, you get sick. You know, you've only got so many soldiers. You've only got so many B cells and T cells out there doing things. And if you're fighting this, oh, I'm worn out, oh, I gave blood, oh, I did drugs over the weekend, you know, whatever you did, and then you get a vaccine and you're like, oh, I got sick. Big surprise. Look at diet, look at hydration, look at exposure, look at all those things first. You're probably worn to a frazzle and that vaccine just tipped you over the edge. Does that make sense? Okay. Now, should you feel a little redness? Should you feel like you're fighting something? That's a good thing. Why? Because it's working. Your immune system is like, wow, I don't recognize this antigen. Bring in the troops. We're going to attack it. Does that make sense? And do vaccines stop you from getting sick all the time? No. The whole point of vaccine isn't to try and get you from, stop you from getting sick. What's the point? It's trying to reduce you being in the hospital, reduce serious complications, reduce the chance of you dying. Okay? Are you still going to get COVID? Yeah, if you're vaccinated. Are you still going to get influenza? Yeah, but hopefully it's not as severe because you've trained the immune system. Does that make sense? Okay? Yeah.
I also heard that as a reason not to get the vaccination because you're still going to get it anyway.
Well, I'd rather not be intubated than, and have an easier time and maybe even be asymptomatic than have a severe thing. Yeah. Okay. All right. right. Yeah, I had Huh? That's right, because what if you had just a mild case, you didn't build up your T cells, right? Right. Yeah. I know. You know, somebody in my class probably 10 years ago. And we were talking about this very thing about vaccines. And this student raised her hand and said, well, I'm not going to vaccinate my child because, you know, they should get sick. It makes them stronger.
Builds your immune system.
It builds your immune
That's
system.
what my aunt said.
Yeah, and she did that, and I thought, wow, I'm so glad you're not my mother. You know? You know? Why should you suffer? What are we trying to do in medicine? We're trying to prevent suffering and treat the suffering we see, right? That's what we're trying to do. And, yeah. Don't lick a bunch of doorknobs. Okay. Yeah.
If I don't vaccinate my kids when they're small, and then they grow up and as adults they want to get vaccinated for all these things that I do for them, is it possible or is it too late?
No, you can always get a lot of these vaccines. Yeah, it's totally possible. Yeah. So, all right. So we saw herd immunity up here. What is herd immunity? Okay? I love this picture. Okay? Not immunized but still healthy. And if you get something like measles that has an R naught of 12, most of your population will get what? Sick. Okay? If you have immunized and healthy, okay, and most of the population is immunized, you're not going to have that many cases. Okay? Look at, and you can see this from data that we've had this semester. Where in Texas, where the measles outbreak started, what population did it start in? Yeah, like the Amish, who do not vaccinate. And it decimated, okay? A lot of sick kids. And I don't like measles because once you get it, it screws up your B cells and T cells. So you lose a lot of your memory that you've had accumulated your entire life. It's called an immunomodulator, okay? COVID is an immunomodulator. Measles is an immunomodulator. Polio is an immunomodulator. It changes things in your immune system, okay? So what happens? Now you can't remember what infections you have. So you need to get a certain percentage of herd immunity for a lot of these. And for some of these diseases, you have to have a lot more vaccination than some of the others. Does that make sense? Okay, so this is children. This blows me away. I've started thinking about this one for a long time. This is a percentage of U.S. children born in 2013 that completed all the CDC vaccination series by 2016. Okay? The darker it is, the better the vaccination. What states have high vaccination rates? North Dakota, Nebraska, Texas, Pennsylvania. Okay? Where do you have low vaccination rates? Nevada, Wyoming, Montana. Okay? Interesting. Texas is so flipped in the last, yeah. But, yeah, times are all changing. Yeah. Isn't that funny?
That's not funny.
It's not funny. Okay, let's look at some herd immunity data. Some of these diseases, like pertussis, you need 92 to 94% of your population vaccinated in order to suppress it in the population. Okay? That's pretty high. You know why? It's because they made the pertussis vaccine a little too weak. And so it says you can have it every 10 years, but in healthcare you get it every 5 years, and some places make you get it every 3 years. What's the vaccination for pertussis? Card time. What is your vaccination for pertussis? What's it called? This is on your first quiz. It was Tdap, DTaP, or TD, right? But not TD part, because that's the, okay? All right, so as you go through here, remember what your vaccines are, okay? We only need about 75 or 80 to 86% to get the mumps threshold, okay? That's good. Mumps isn't very comfortable, okay? All right, and what is the R naught value? What does this value mean? Yep, how many other people get sick when one person gets sick? Very good. Okay. Now, slide 11 and 12. Put a star on slide 11 and 12. Why? Because I'm going to ask you this on the exam. I'm telling you, you're gonna see this. This would be a really good matching section, wouldn't it? You're like, no. Okay. So here's your immune system. You have innate and acquired. And acquired, you either have active or passive. Okay? When do you get passive made antibodies? Well, you get them from mommy. Which antibody crosses the placenta?
IgG.
Okay, IgG. So it'll stick around for a little while. And you can get antibodies from other sources. You're like, how does this work? They give an IV thing. It's called IVIG. Okay, what does it stand for? Intravenous immunoglobulin. There are a lot of people wandering around that have genetic reasons for their immune system to be suppressed. So what do? They go in every so many months, every 3 months, sometimes every 2 months. They get an infusion of antibodies, okay? That'll give them some added protection. Now, where did those antibodies come from? Donors, yeah. So oftentimes on campus, you see LifeStream here. What are they collecting? Whole blood, right? What do plasma centers collect? Plasma. Where are the antibodies? In plasma, right. So when you see a plasma collection center, okay, where are they? Are they in the ritziest part of town? No. They're in the population, the part of town where the population sees everything all the time. Why? Because they have the richest antibodies. You're always going to see plasma centers in like the crappy parts of town. Why? Because they're hoping homeless, right? Yeah, you get paid a lot of money for plasma. Yeah. Plasma? Yeah, it's like $50 or something. Yeah. Do they take all your blood out? No, they just take the plasma and they pay you money and they pool that together. When's another time that we saw antibodies from other sources? If you remember when COVID came out, before we had a vaccination, they were asking for donors. If you have survived COVID, come and donate your blood so we can give your antibodies to somebody that's doing really poorly. Remember that? Okay, so we've seen a couple of examples of that. Okay? All right, so let's take this acquired immunity, this part right here. You're watching? Okay, and let's look at acquired immunity. It's natural, okay? It means you got it passively or actively, where you developed an immune response to an antigen, and we have artificial. Okay, where would vaccines be? Artificial active. Good. Getting COVID antibodies, which one would that be? The active, artificial, passive. Okay, What would be getting a cold from your neighbor?
Natural active.
Natural active. Good. Okay. Can you see why this would be a really bitchin' matching section? Okay. So you got those down. Okay. All right. Isn't this stuff cool? This is really just amazing. Okay. Okay. Let's talk about different types of vaccination. Okay. Look at the root of the word. What does it mean? What does inactivated mean? If something's inactivated, what does it mean?
Say can't touch it.
Can't hurt you. Okay. What does attenuated mean?
It's alive.
It's alive but altered.
It's alive but altered. It's been changed. When you see attenuated, they change. Okay? All right, cool. By the way, how many different COVID vaccines are there on this planet? Close to 20. Yeah. Yeah, because I mean, there's the mRNA platform that we use in the United States. There's Novavax that's available in the United States, which is protein-based. Okay, there's other protein-based ones. Yeah, so there's all different kinds. We tend to be pretty U.S.-centric, but when you're talking about global health, you got to look at everybody. Which country came out with the first vaccine? Russia. Yeah. Okay. I hear it's crap, but whatever. I wasn't gonna take it. Okay, so you've seen this here, live attenuated whole vaccines. Okay, what's some examples of this? Okay, MMR, TB, the Sabin polio. There were 2 polio vaccines. One was Sabin, and the other was Jonas Salk. Okay, chickenpox. Okay, this is a great way to go. Okay, except for one population. Which population is this? The immunocompromised. You don't want to give a live vaccine to anybody who's in the immunocompromised. Very young, very old, or had something, HIV, cancer, okay? All right? But they're really very, very effective. So most of the vaccines that we see now are inactivated virus or bacteria. So they're dead. They can't reproduce. But because they can't do that, that still means the antigens are there, okay? So that's a Salk, polio, rabies, influenza, hepatitis, okay? All right, I don't know why rabies is twice, but, okay? So that's the inactivated. Okay, the subunit one. This is really clever how they do this. Okay? What they do for the subunit vaccine is they usually take part of the capsid. Remember when we talked about viruses, the capsid is what? The protein. And they have little capsomeres that are part of that. Okay? So they can take that protein from the parts, okay, reproduce it in a bacteria, okay, and then inject it into us. This is exactly what they did for pertussis, okay? They used to have a live vaccine for it. There were too many adverse reactions, so they tried this way to do it. Okay, now, what's the bad part about this? The challenge is you're gonna have to have boosters with this. Oftentimes, just little antigens isn't enough to give you full protection. Because remember this, okay? If you've got something, a bacteria, you want to do it, and it's got all these different surface proteins, I'll just make little squiggles to all the different surface proteins, okay? Where can you make antibodies to? Where do you make antibodies to? Anywhere. You can make them to here, you might make them to this one, you might make it to a glycoprotein. You can do that. That's what's part of your natural immunity, is that once your body recognizes something's foreign, it can make antibodies to any region, okay? But if you're only given this little region, is it going to be as good as getting all of that? No, okay? That's why subunit vaccines, you need multiple boosters, okay? All right, that's an ugly drawing, but it did make sense?
Yeah.
Okay. All right, let's talk about toxoids. Okay? Diphtheria and tetanus are the two toxoid vaccines. Okay? Get it all here. All right? Now, I want you to pay attention to this. It's not the virus. It's not the bacteria you're making antibodies to. What are you making antibodies to? The toxins. And what are most toxins? Proteins. Proteins. Okay? The botulinum toxin is a protein. So what do? We take these, put it in a cell, okay? And you get a cell damaged by the toxin. But we can also culture cells so that we can have the toxin molecule and the cells can develop antibodies to it. And then that is the antitoxin right there. Okay? That is the antitoxin. Okay? And when you give these antibodies, it recognizes those antigens and that helps. It's very different from what we've seen before. Does that make sense? Okay. All right. Those are the toxoids. It's only two. Okay. Subunit vaccines. Okay. We've kind of gone through this again with this beautiful picture. Okay. They're really easy to make. The way that we do this is that we take a virus and look, we put the genes into a plasmid and then put it into yeast, and yeast will make billions and billions of copies, and then we isolate this, and here we go. We've got our vaccine. Okay? So, yeah. Okay. All right. How are we doing? This is a scary slide. Okay? We've already talked about, immunoglobulins, and we look at immunoglobulin titers and temporary protection. Okay? Let's talk about how we make preformed antibodies. Okay? All right? I don't know if you know this, but Loma Linda is one of the biggest snake venom repositories in the country. Did you know that? Yeah. One of the snake venom guys used to teach as a part-time instructor here. I think he's retired, but he would collect snake venom from all over. So if you get bit by a rattlesnake out here, this is a good place to be because they got something to treat you with. But what is venom? What kind of molecule is venom? It's a protein. Yeah, venom is a protein. Okay? So when we make an antivenom, we take this and we inject it into a horse. Okay? Why? Because horses are big and they make lots of antibodies. And then we take their plasma and extract the antibodies, and then we can give it to patients. Okay? And you're like, how come they do that to the horsies? I don't know. Yeah, but this is kind of, So there are certain preparations like diphtheria, botulism, and spider and snake venom. They can give you some things, but it's not going to be on the shelf. I'll tell you what, they usually have to do it. Okay. So I asked a question on the exam about the VIR drugs, VIR. Do you remember that question on the exam? Yeah, I said, okay, what kind of illness would this, Rapavir or something, treat? And it should have been viral, right? Because VIR is an antiviral. Remember this one, okay? These are antibody-based drugs. You are going to see more and more of these as you practice medicine. Why? Because they're antibodies, so they're going to be very specific. They're great. Are there side effects with them? Of course. There's side effects for everything. Okay? But how do you know you're dealing with an antibody drug. AB, 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 AB. Look at that. So, next time you're watching TV or Hulu or Netflix or something and you get a drug commercial come on, read what the actual name is, not the commercial name. But read the name and see, is it an antibody drug? Keytruda, we've had great success with Keytruda. That's an anti-cancer. And they're using it in almost all metastatic cancers now, Keytruda, because what does it do? It recognizes proteins on cancer cells, okay? Remicade, Humira, okay? Antivo, Xolair, what are they? They're antibodies that are trying to block something, okay? So, anyway, it's monoclonal antibody. The reason monoclonals are good, what does mono mean? One. So it is very specific. If you had a polyclonal antibody, would it be as specific? No, poly means what? Multiple, many. So if you're going to give a drug that targets a particular protein, what would you rather have, a monoclonal antibody or a polyclonal? Have a monoclonal. Works better every time, okay? Is that cool?
I got a question.
Yeah.
So we only need to know that ending, not all of the actual drugs?
No, I don't care that you know drugs.
Okay.
But if you see a drug ending with MAB, you know it's monoclonal. Yeah. Now, those of you who've been in the clinic to see some of these monoclonals, are there side effects? Yeah. But they usually only give these if the physician thinks the benefit is going to be outweighed.
I'm sorry, did you say ADE is for monoclonal?
No, MAB. It's right here. MAB, monoclonal. Okay. Yeah. Okay. Yeah. Okay. Here's the RNA vaccine. Okay. COVID vaccines, Johnson & Johnson, AstraZeneca. Okay, we've kind of already talked how this works. What is the advantage? You can develop on the mRNA platform, so it's very specific and you can change quickly. Those are the two advantages, is you can, mass produce this pretty well and, it can change quickly, okay? So I'm going to go through and it shows it, how this works, okay? Now, the challenge with Pfizer and Moderna is that this thing, you've got mRNA and you got fat around it. What happens when this comes up to room temperature for a while? What's going to happen to all those fat little things, those fatty things? They're all greasy. If you get up to room temperature, what happens? They merge together. We don't want that. That's why these two vaccines have to be kept at such a low temperature, is to keep those little micelles, keep those things apart. Okay? That's one of the reasons why you had to register to get a COVID vaccine, is they didn't want to thaw one out for one person. They wanted to get you in a group so it didn't stay. I mean, we don't think that, 0 degrees Celsius is warm, but for these things it is. So that's why they always had you come at certain times, is so that they could have that vaccine, not sitting around too long, okay? Now, I read last night that they've got a new vaccine out that doesn't have the temperature requirements, and I'm excited to see what it is. But I read it online, so I don't know. Okay, so we go through what the ideal vaccine is, okay, what the schedule is, what do we do? We're trying to prevent people from suffering. That's all we're trying to do. Are we going to be 100% at it all the time? No. But we can try, right? Okay. So, that wraps up the rest of 15. Let's start 16. Okay, this is 16. Okay? Now, chapter 16 is all about immunological disorders and hypersensitivities and it's fascinating. Okay? And some of the things in this chapter you've already had, like ABO blood groups and RH factor, right? You've had that. You had that in Bio 1, you had that in anatomy. That's kind of a nice review. Okay? There's some definitions in this chapter. Okay? Make sure you know the definitions. Okay? And then we've got these disorders, and we're going to start talking about hypersensitivities. Okay? Bless you. Okay. How many of you had allergies this spring? It was a holy crap, year, wasn't it? Okay? As we see climate change happen, they're going to get worse. I know, I'm the Eeyore of microbiology, but it will get worse. Why? Because there's more rain, there's freaking pollen, there's invasive plants, and all this stuff. How many of you are allergic to pollen? Okay, what is pollen? Protein-covered sperm. That's really all it is. You got a couple of sperm cells in there, and it's coated, and often these are spiky, so it can stick on the stigma of the plant. Okay? All right? How many are allergic to different foods? Okay, right on. Okay? Now, is it normal to be hypersensitive to pollen and food? No. What's happening to your immune system? It's overreacting. It should be reacting like this. But what does it do? It reacts like that, right? Much rather be here. Okay. So, there are all different kinds of hypersensitivities. I'm going to give you the big cheat sheet for knowing what your hypersensitivities are. Okay? If you read through this, you know there's type 1, type 2, type 3, and type 4, right? Hypersensitivities. Okay? The way I remember this, okay? Acid. Alright? Acid. Okay, what do I mean by this? This is allergic, asthma, anaphylaxis. Okay? All the things, okay? These deal with mast cells. If you don't remember mast cells, go back and read about the mast cells, okay? Yeah, anaphylaxis. This is allergic. All the things allergic. Okay, let's look at C. C stands for cytotoxic. When you see cytotoxic, okay, what kinds of cells should you think about? Yeah, usually T cells. Okay? But it's a little bit more than that. You're going to be using IgMs and IgGs. Okay? You get complement activation. Okay? And it's cytotoxic to your cells. So you're going to get some kind of cell destruction in there. Okay? I stands for immune complex. Okay? All right? And what I like to think of is lumpy, bumpy. Okay? Lumpy, bumpy. Why? Because when you hear of immune complex, we learned this last exam. What is an immune complex? It's an antigen that has what? Bunch of things bound to it. Makes these big, lumpy, bumpy things. And what happens? These get deposited in the tissues. Okay? All right? Lumpy, bumpy. Okay. All right? So, D is for delayed. Okay? So, what happens? This means that the cytokines have to activate the macrophages, and then the macrophages go on and do this. How do we use this for? To diagnose TB. Okay? Think about when you go in for a TB test. How many days does it take? 2 to 3, right? 2 to 3 to do that. Why? Because it's delayed. Okay? It's got to increase the cytokines, and then it's got to increase this, and then you see this delayed reaction. Okay? What else? This is also type 1 diabetes. Okay? Type 1 diabetes, what do we know about type 1? Type 1 is, these called juvenile diabetes. This is where you make your immune system attacks the islet cells in the pancreas, right? Okay? All right. So as you go through all of these, you know, for your hypersensitivities, this is the easiest way I can think of to put it all together. Okay? Now, you can make a mind map of this. Start with acid. Remember all that. And then think about those that go different places. So, this is kind of the view from above. Okay? Is that cool? Okay. So, with that said, what? Oh yeah, this is just the big picture where to start from when you're trying to understand what's going on. Because a lot of people try and learn this linearly, and it's hard. So if you can remember acid, do that. Then with your PowerPoints, fill in. Okay, what things are, you know, cytotoxic? What is this? What is this? Okay, but this is the big picture outline. Does that make sense? Okay. Yeah. Okay, I got 5 minutes. I don't want to give up 5 minutes. Ooh, wait. Okay. Here we go. Sensitivities. Let's look at this real quick. Oh, yeah. Ah, what is this? There's some pollen. What is this? Poison ivy. Have you ever had the joy of having this done to you? No. Oh, I should bring in my kit. That's in my office. It has hundreds of these. So you just open up. I'll bring that next time. I gotta remember to bring it. What is going on here? Yeah, it's an allergen test. Okay? So what do? They scrape and put allergens in your skin and they wait for you to react, and then they say, oh, looky here, you're allergic. And then you're like, man, you must hate me. What is the deal here? Okay? We can do the same thing. We can actually get this to go. I should have done this at the beginning of class, but if you take your fingernail, okay? I don't want blood, but start on the most tender skin of your arm and make a line. Just run it across there. Okay? Yeah. Wow, I'm reactive today. No kidding. My allergies have been off the charts. Okay? But we had a contest one time of how long the red mark stayed. Okay? And the record, you want to guess what the record was?
6 hours.
Oh, I don't know. I didn't call her in the middle of the night, but it's like 2 hours and 40 minutes. Okay? Why? Why would she react to something like that so much? She was pregnant. Okay? If you've had COVID recently, you can react. If you have allergies recently, okay, you can react. Okay? Yeah. Wow, that's nice, Andrew. I think you might be pregnant.
We were just talking about
Okay. All right. So, we've got a couple minutes left. Does it help to go over the lectures like this rather than reading slides?
Yes.
Okay, good. So we're going to do that. So next time I see you, we'll come on in and we'll have your last Wizzy, and then we'll do chapters 16 and 17, and then on Sunday we'll have a little party, a knowledge festival. Yay!